Hello everyone, and welcome to Bilal Consultancy. Today, we're going to talk about an important quality tool, the Box and Whisker plot. Don't worry, we'll explain it in simple terms. What is a Box and Whisker plot? Also called Boxplot, Box and Whisker diagram, Box and Whisker plot with outliers. A Box and Whisker plot is defined as a graphical method of displaying variation in a set of data. In most cases, a histogram analysis provides a sufficient display, but a Box and Whisker plot can provide additional detail while allowing multiple sets of data to be displayed in the same graph. Why use a Box and Whisker plot? Box and Whisker plots are very effective and easy to read, as they can summarize data from multiple sources and display the results in a single graph. Box and Whisker plots allow for comparison of data from different categories for easier, more effective decision-making. History of Box and Whisker plot? The Box and Whisker plot, also known as a Boxplot, is a graphical representation of the distribution of a dataset. It provides a visual summary of the minimum, maximum, median, first quartile, and third quartile of the data. The concept of the Box and Whisker plot can be traced back to John Tukey, an American mathematician and statistician, who introduced it in the 1970s. Here's a brief historical overview of how the Box and Whisker plot evolved. Early concepts, 19th century. The representation of statistical data dates back to the 19th century when statisticians and mathematicians explored various ways to visually display data distributions. However, the specific Box and Whisker plot as we know it today was not developed during this time. John Tukey and the Boxplot, 1970s. John Tukey, a prominent statistician, introduced the Box and Whisker plot in the mid-1970s as part of his toolkit for exploratory data analysis, EDA. Tukey's goal was to provide a simple and effective way to display the distribution of a dataset and to identify potential outliers. Introduction of the Box and Whisker plot. Tukey published the Box and Whisker plot as part of his exploratory data analysis techniques in his book, Exploratory Data Analysis, in 1977. The plot was designed to display the summary statistics of a dataset, including the median, quartiles, and outliers, in a visually informative way. Widespread adoption and usage. The Box and Whisker plot gained popularity rapidly due to its effectiveness in representing the key features of a dataset. It became a widely used tool in various fields, including statistics, data analysis, and quality control. Further refinement and variations. Over the years, statisticians and researchers have refined the Box and Whisker plot and introduced variations to enhance its capabilities. These variations include notched box plots, violin plots, and other adaptations that provide additional information about the data distribution. Today, the Box and Whisker plot is a fundamental tool in statistical analysis and is commonly used in various disciplines to visualize and analyze data distributions, detect outliers, and compare multiple datasets efficiently. Its simplicity and effectiveness have solidified its place in the toolkit of data analysts and researchers worldwide. When to use a Box and Whisker plot? Use Box and Whisker plots when you have multiple datasets from independent sources that are related to each other in some way. Examples include test scores between schools or classrooms, data from before and after a process change, similar features on one part, such as camshaft lobes, data from duplicate machines manufacturing the same products. How to make a Box and Whisker plot. The procedure to develop a Box and Whisker plot comes from the 5 statistics below. You can also download the Box and Whisker plot template. Minimum value, the smallest value in the dataset. Second quartile, the value below which the lower 25% of the data are contained. Median value, the middle number in a range of numbers. Third quartile, the value above which the upper 25% of the data are contained. Maximum value, the largest value in the dataset. For example, given the following 20 data points, the 5 required statistics are displayed. For a data set with an even number of values, the median is calculated as the average of the 2 middle values. The data represented in Box and Whisker plot format can be seen in Figure 1. Box and Whisker plot example. Suppose you wanted to compare the performance of 3 lathes responsible for the rough turning of a motor shaft. The design specification is 18.85 plus 0.1 millimeters. Diameter measurements from a sample of shafts taken from each roughing lathe are displayed in a box and whisker plot in figure. Lathe 1 appears to be making good parts, and is centered in the tolerance. Lathe 2 appears to have excess variation, and is making shafts below the minimum diameter. Lathe 3 is performing with relatively less variation than Lathe 2. However, it is centered on the lower side of the specification and is making shafts below specification. Components of box and whisker plot. A box and whisker plot, also known as a boxplot, is a graphical representation of the distribution of a dataset. It displays the summary of a set of data points including the minimum, first quartile, median, third quartile, and maximum. The plot is used to visually identify the spread and skewness of the data along with outliers. Let's delve into the components and types of box and whisker plots in detail. Components of a box and whisker plot. Minimum and maximum, whiskers. The minimum and maximum values of the dataset, excluding outliers, are represented as lines, whiskers, extending from the ends of the box. The whiskers show the range of the data. Quartiles and median, box. The box is divided into 3 parts by 2 horizontal lines. The line in the middle represents the median, the middle value of the dataset when it's arranged in order. The other 2 lines mark the first quartile, 25th percentile, and the third quartile, 75th percentile, of the data. Interquartile range, IQR. The range between the first quartile, Q1, and the third quartile, Q3, is known as the interquartile range, IQR. It gives an indication of the spread of the middle 50% of the data. Outliers. Any data points that fall significantly beyond the whiskers are considered outliers. Outliers are individual data points that are significantly different from the rest of the data. Types of box and whisker plots. Standard box and whisker plot. The standard box and whisker plot display the minimum, first quartile, median, third quartile, and maximum of the dataset. Notched box plot. This type of box plot includes a notch around the median, providing a rough guide to the significance of differences between groups. If the notches of 2 box plots do not overlap, it suggests that the medians are significantly different. Violin plot. A violin plot combines a box plot and a kernel density plot. It displays the distribution of the data and includes the quartiles, median, and range. The density plot on each side of the box plot provides a deeper understanding of the data's distribution. Modified box plot. Modified box plots can have variations in the way the boxes and whiskers are drawn, or they may include additional elements like mean, confidence intervals, or other statistical measures. Grouped box plot. In a grouped box plot, multiple box plots are displayed side by side, allowing for easy comparison of different datasets or categories. Understanding these components and types of box and whisker plots can help in effectively analyzing and visualizing the distribution and spread of data, making it easier to identify patterns, outliers, and variations within the dataset. How to develop it step by step. Creating a box and whisker plot involves a series of steps to represent the distribution of a dataset in a graphical and informative manner. Here's a detailed step-by-step guide to creating a box and whisker plot. Step 1. Collect and organize data. Collect the data you want to represent in the box and whisker plot. Ensure that the data is organized in a clear and structured format, such as a list or table. Step 2. Arrange data in ascending order. Arrange the data in ascending order to easily calculate the quartiles and median. Step 3. Calculate quartiles and median. First quartile, Q1. Find the median of the lower half of the data set. If the data set has an odd number of observations, Q1 is the middle value. If it has an even number, average the 2 middle values. Median, Q2. Locate the middle value of the entire data set. If the data set has an odd number of observations, this is straightforward. If it has an even number, average the 2 middle values. Third quartile, Q3. Find the median of the upper half of the dataset. Similar to Q1, if the dataset has an odd number of observations, Q3 is the middle value. If it has an even number, average the two middle values. Step 4. Determine minimum and maximum values. Identify the minimum and maximum values in your dataset. These values will represent the ends of the whiskers. Step 5. Calculate interquartile range, IQR. Calculate the interquartile range, IQR, by subtracting Q1 from Q3. IQR equals Q3 Q1. Step 6. Identify outliers. Determine the lower outlier bound, Q1 1.5 * IQR. Determine the upper outlier bound, Q3 plus 1.5 * IQR. Any data points outside these bounds are considered outliers. Step 7. Draw the box and whisker plot. Draw a number line that includes the minimum, first quartile, Q1, median, Q2, third quartile, Q3, and maximum values. Draw a box from Q1 to Q3, with a line representing the median, Q2, inside the box. Extend lines, whiskers, from the box to the minimum and maximum values. Mark any outliers outside the whiskers. Step 8. Label the plot. Label the axes, if applicable, and provide a title for the plot. Additionally, label the whiskers, box, median, and any outliers for clarity. Step 9. Interpret the plot. Analyze the box and whisker plot to understand the distribution of the data, the presence of outliers, and the spread of values within the dataset. By following these steps, you'll be able to create a clear and informative box and whisker plot to represent the distribution of your dataset effectively. Importance. Using a box and whisker plot helps businesses understand the variability in their processes or products. By identifying outliers, we can pinpoint potential issues that need attention and improvement. Conclusion. And that's it. Box and whisker plots are a powerful tool for understanding and improving quality. If you found this video helpful, don't forget to like and subscribe to Bilal Consultancy for more simplified explanations on useful topics. Thank you for watching.